NoSQL database. What is NoSQL? NoSQL databases are non-relational databases. They do not require a fixed predefined schema, no structured tables with row and columns. NoSQL databases are purpose-built and optimized for many modern applications. They are a great fit for mobile, web, and gaming applications that require large data volume, low latency, high performance, and flexible data models to provide great user experiences. Here is an example of modeling the schema for a simple book database. In a relational database, a book record is stored in separate tables, and relationships are defined by primary and foreign key constraints. The books table has columns for ISBN, book title, and edition number. The authors table has columns for author ID and author name. And the author ISBN table has columns for author ID and ISBN. The relational model is designed to enable the database to enforce data integrity, normalized to reduce the redundancy, and generally optimized for storage. In a NoSQL database, a book record can be stored as a JSON document. For each book, the item, ISBN, book title, edition number, author name, and author ID are stored as attributes in a single document. In this model, data is optimized for intuitive development and horizontal scalability. Why should you use a NoSQL database? Flexibility. Flexible schemas enables faster and more iterative development. Scalability. NoSQL databases are generally designed to scale out by using distributed clusters of hardware instead of scaling up by adding expensive and robust servers. High performance. NoSQL databases are distributed and fit for massive parallel high-performance data processing across processing nodes and servers. This enables higher performance than trying to accomplish similar functionality with relational databases. Highly functional. NoSQL databases provide highly functional APIs and data types that are purpose-built for each of their respective data models. NoSQL databases use a variety of data models. Key value. A key value database uses a simple key value method to store data. The key serves as a unique identifier. They are highly partitionable and allow horizontal scaling at scales. Use cases include gaming, advertising technology, and IoT. Amazon DynamoDB is a key value database. Document. A document database is designed to store and query data as JSON-like document. This makes it easier for developers, as they are using the same document model format as their application code. Typical use cases include catalogs, user profiles, and content management systems where each document is unique and evolves over time. Amazon Document DB with MongoDB compatibility, and MongoDB are popular document databases. Graph. Graph databases are purpose-built to store and navigate relationships. Nodes store data entities. Edges store relationships between entities. An edge always has a start node, end node, type, and direction, and an edge can describe parent-child relationships, actions, ownership, and the like. Typical use cases include social networking, recommendation engines, fraud detection, and knowledge graphs. Amazon Neptune is a fully managed graph database service. Popular graph databases include Neo4j and Giraffe. In-memory. An in-memory database relies primarily on memory for data storage, in contrast to databases that store data on disk or SSDs. They are designed to attain minimal response time by eliminating the need to access disks. In-memory databases are ideal for applications such as gaming leaderboards, session stores, and real-time analytics. These applications require microsecond response times and can have large spikes in traffic coming at any time. Amazon ElastiCache offers memcached and Redis. Amazon DynamoDB Accelerator DAX is another example, which makes DynamoDB reads an order of magnitude faster. Search. A search engine database is dedicated to the search of data content. Search engine databases use indexes to categorize the similar characteristics among data and facilitate search capability. Typical use cases are text search, logging, and analysis. Amazon Elasticsearch Service is a powerful, high-performance search engine for full-text search use cases. Amazon DynamoDB Overview. Amazon DynamoDB is a key value and document database. It delivers single-digit millisecond performance at any scale. It's a fully managed, multi-region, multi-master, durable database with built-in security, backup and restore, and in-memory caching for internet-scale applications. DynamoDB can handle more than 10 trillion requests per day and can support peaks of more than 20 million requests per second. Here are the key benefits. Performance at scale. DynamoDB is a key value and document database that can support tables of virtually any size with horizontal scaling. It enables flexible schema, which allows you to adapt to your business requirement change easily. For use cases that require even faster access with microsecond latency, DynamoDB Accelerator DAX provides a fully managed in-memory cache. Using DAX, you can improve the read performance of your DynamoDB tables by up to 10 times. The time required for reads reduces from milliseconds to microseconds, even at millions of requests per second. DynamoDB global tables replicate your data across multiple AWS regions to give you fast, local access to data for your globally distributed applications. DynamoDB streams capture a time-ordered sequence of item-level modifications in any DynamoDB table and store this information in a log for up to 24 hours. DynamoDB provides both provisioned and on-demand capacity modes. Tables using provisioned capacity mode require you to set read and write capacity. For workloads that are less predictable, on-demand capacity mode takes care of managing capacity for you, and you only pay for what you consume. With the two capacity modes, you can optimize costs by specifying capacity per workload or paying for only the resources you consume. For tables using on-demand capacity mode, DynamoDB instantly accommodates your workloads as they ramp up or down to any previously reached traffic level. For tables using provision capacity, DynamoDB delivers automatic scaling of throughput and storage. If your application traffic grows, DynamoDB increases throughput to accommodate the load. If your application traffic shrinks, DynamoDB scales down so that you pay less for unused capacity. DynamoDB integrates with AWS Lambda to provide triggers. With triggers, you can build applications that react to data modifications in DynamoDB tables. The Lambda function can perform any actions you specify, such as sending a notification or initiating a workflow. Encryption at rest. DynamoDB encrypts all data by default. Encryption at rest enhances the security of your data by using encryption keys stored in AWS Key Management Service. ACID transactions. It provides native, server-side support for transactions, simplifying the developer experience of making coordinated, all-or-nothing changes to multiple items both within and across tables. Point-in-time recovery, PITR, helps protect your DynamoDB tables from accidental write or delete operations. PITR provides continuous backups of your DynamoDB table data. You can recover to any point in time up to the second during the preceding 35 days with no downtime. On-demand backup and restore. You can create full backups of hundreds of terabytes of data instantly with no performance impact to your tables. The archived data can help you meet your corporate and governmental regulatory requirements. DynamoDB is also backed by a service-level agreement for high availability. Difference between SQL and NoSQL databases. There are a few key differences between SQL and NoSQL databases. Optimal workloads. Relational databases are designed for transactional and strongly consistent online transaction processing (OLTP) applications. They're also good for online analytical processing (OLAP). On the other hand, NoSQL key value, document, graph, and in-memory databases are designed for OLTP for a number of data access patterns that include low latency applications. NoSQL search databases are designed for analytics over semi-structured data. Data model. The relational model normalizes data into tables that are composed of rows and columns. A schema strictly defines the tables, rows, columns, indexes, relationships between tables, and other database elements. The database enforces the referential integrity and relationships between tables. NoSQL databases provide a variety of data models that includes key value, document, graph, in-memory, and search. Or you can design custom data models based on your specific query patterns. ACID properties. Relational databases provide atomicity, consistency, isolation, and durability, ACID, properties. Atomicity requires a transaction to execute completely or not at all. Consistency requires that when a transaction has been committed, the data must conform to the database schema. Isolation requires that concurrent transactions execute separately from each other. Durability requires the ability to recover from an unexpected system failure or power outage to the last known state. DynamoDB transactions provide developers ACID across one or more tables within a single AWS account and region. NoSQL database is an excellent choice for high-throughput, low-latency use cases that need to scale horizontally beyond the limitations of a single instance. Performance. Performance is generally dependent on the disk subsystem. The optimization of queries, indexes, and table structure is often required to achieve peak performance. On the other hand, performance is generally a function of the underlying hardware cluster size, network latency, and the calling application. Scale. Relational databases typically scale up by increasing the compute capabilities of the hardware, or scale out by adding replicas for read-only workloads. NoSQL databases typically are partitionable because key value access patterns are able to scale out by using distributed architecture to increase throughput. APIs. Requests to store and retrieve data are communicated using queries that conform to a structured query language, SQL. Object-based APIs allow app developers to easily store and retrieve in-memory data structures. Partition keys let apps look up key value pairs, column sets, or semi-structured documents that contain serialized app objects and attributes. Create and query a NoSQL table with Amazon DynamoDB. Before we talk about how to create a table, let's go through a few basic terms about a DynamoDB table. A table is a collection of data, which we call items. Each item has some characteristics, which we call attributes. Each item in the table has a unique identifier, or primary key. DynamoDB supports two different kinds of primary keys, partition key and sort key. The partition key is mandatory. DynamoDB uses the partition key's value as input to an internal hash function. The output from the hash function determines the partition, physical storage internal to DynamoDB, in which the item will be stored. The partition key enables partition for scale. The sort key is optional. It provides additional flexibility for querying data. Now, let's look at how you can create a simple table with Amazon DynamoDB service. We will use a music library in this example. To create a DynamoDB table, first, simply enter the table name, in this case, music. Next, enter a partition key, in this example, artist. Because each artist may write many songs, you can enable easy sorting with a sort key. In this example, use song title as the sort key. Next, enable auto-scaling. Finally, just create the table. The music table is created and ready to use. You can add data to the table by creating data record called item. In this example, enter the artist name and song title for each item. There are two ways of searching data, query or scan. In a query operation, you must specify a partition key value. Sort key is optional. For example, you can search by artist and also narrow down the search results by song title. On the other hand, a scan operation always scans the entire table. By default, it returns all of the data attributes for every item in the table. If an optional filter expression is provided, it then filters out values to provide the results you want. To delete an existing item from a table, you must specify the primary key value to delete one item at a time. For applications that need to read or write multiple items, DynamoDB provides the batch operations. In addition, DynamoDB performs the individual read or write operations in parallel. Your applications benefit from this parallelism. Amazon DynamoDB scans. Overview. A scan operation in Amazon DynamoDB reads every item in a table or a secondary index. By default, a scan operation returns all of the data attributes for every item in the table or index. Therefore, the best practice is to avoid using a scan operation on a large table or index with a filter that removes many results. A single scan operation can retrieve a maximum of 1 megabyte of data. For example, here is a DynamoDB scan using the AWS command line interface, AWS CLI. The DynamoDB scan CLI command is used to scan the music table. You can use the projection expression parameter so that scan only returns some attributes rather than all of them. In this case, only the album attribute values are returned. If you need to further refine the scan results, you can optionally provide a filter expression. A filter expression determines which items within the scan results should be returned to you. A filter expression is applied only after the entire table is scanned or a scan finishes. The expression does not consume any additional read capacity units. With scan, you can specify any attributes in a filter expression, including partition key and sort key attributes. The syntax for a filter expression is identical to that of a condition expression. Filter expressions can use the same comparators, functions, and logical operators as a condition expression. In this example, it filters the scanned results by artist 2. Therefore, only the list of albums by artist 2 are returned. Now, let's look at some of the key features. Limiting the number of items in the result set. You can limit the number of items in the result set by setting the limit parameter to the maximum number of items that you want prior to filter expression evaluation. For example, suppose that you scan a table with a limit value of 4, and without a filter expression, the scan result contains the first 4 items from the table that match the key condition expression from the request. Now suppose that you add a filter expression to the scan. In this case, DynamoDB applies the filter expression to the 4 items that were returned, discarding those that do not match. The final scan result contains 4 items or fewer, depending on the number of items that were filtered. Counting the items in the results. The scan response contains the following elements: scan count and count. Scan count is the number of items evaluated or scanned before any scan filter is applied. Count is the number of items that remain after a filter expression was applied. If the size of the scan result set is larger than 1 megabyte, scan count and count represent only a partial count of the total items. You need to perform multiple scan operations to retrieve all the results. Read consistency for scan. A scan operation performs eventually consistent reads by default. This means that the scan results might not reflect the latest changes due to a recently completed put item or an update item operation. If you require strongly consistent reads, set the consistent read parameter to true in the scan request. Note that a scan operation which performs strongly consistent reads consumes twice as many read capacity units as compared to the default eventually consistent reads. Amazon DynamoDB scans features. Here are the key features. Capacity units consumed by scan. If you scan a table, DynamoDB consumes read capacity units from the table's provisioned read capacity. If you scan a global secondary index GSI, DynamoDB consumes read capacity units from the index's provisioned read capacity. In the case of a local secondary index LSI, DynamoDB consumes read capacity units from the base table's provisioned read capacity. DynamoDB calculates the number of read capacity units consumed based on item size, not on the amount of data that is returned to an application. Paginating the results. With pagination, the scan results are divided into pages of data that are 1 megabyte in size or less. An application can process the first page of results, then the second page, and so on. To determine whether there are more results, you need to scan with the debug mode in order to examine the low-level scan result and check if the result contains the last evaluated key element. In this example, the page size parameter limits the number of items per page. The scan result contains information in the last evaluated key. This indicates that there are more results data available for the operation. To retrieve the next page of information, you will need to set the exclusive start key value to the last evaluated key value, and scan again, until the absence of the last evaluated key in the query result. When there is no last evaluated key, you have retrieved the final page of results. Parallel scan. First, let's understand why parallel scan. By default, the scan operation is sequential. However, the larger the table or index being scanned, the more time the scan takes to complete. In addition, a sequential scan might not always be able to fully use the provisioned read throughput capacity, since a scan operation can only read one partition at a time. The throughput of a scan is constrained by the maximum throughput of a single partition. To address these issues, the scan operation can logically divide a table or secondary index into multiple segments, with multiple application workers scanning the segments in parallel. Each worker can be a thread in programming languages that support multi-threading, or an operating system process. To perform a parallel scan, each worker issues its own scan request, with the segment and total segments parameters. The segment parameter is the segment to be scanned by a particular worker. The first segment number is always 0. Each worker should use a different value for segment. The total segments parameter is the total number of segments for the parallel scan. This value must be the same as the number of workers that your application will use. After each scan, if there is more data, the worker will set the last evaluated key value to the exclusive start key value, and scan again until the last evaluated key value is null. This indicates that there is no more data. Amazon DynamoDB. Queries overview. You can query any Amazon DynamoDB table or secondary index and find items based on primary key values. For the query operation, you must provide the name of the partition key attribute and a single value for that attribute. Query returns all items with that partition key value. Optionally, you can provide a sort key attribute and use a comparison operator condition to refine the search results. Let's start by looking at a DynamoDB query example using the AWS command line interface, AWS CLI. The DynamoDB query CLI command is used to query the music table. If you want to specify search criteria, you can use a key condition expression. The expression contains a string that determines the items to be read from the table or index. You must specify the partition key name, the artist. Optionally, you can provide a second condition for the sort key if present, in this case, the song title, and use the following supported comparison operators. A single query operation can retrieve a maximum of 1 megabyte of data. Query results are always sorted by the sort key value. By default, the sort order is ascending. To reverse the order, set the scan index forward parameter to false. If you need to further refine the query results, after applying the key condition expression, you can optionally provide a filter expression. A filter expression cannot contain partition key or sort key attributes. The expression determines which items within the query results should be returned to you. All of the other results are discarded. It does not consume any additional read capacity (RCUs). The syntax and comparison operators for a filter expression are identical to that of a condition expression. If you need to compare an attribute with a value, define an expression attribute value as a placeholder. They are used as substitutes for the actual values that you want to compare. In this example, we are substituting searched artist with a string value of artist2, searched song title with a string value of song B, and the searched year with a number type value of 2018. With these expressions and substituted values, you can find the item with artist2, song title song B that is released after 2018. Amazon DynamoDB. Queries features. Limiting the number of items in the result set. You can limit the number of items in the result set by setting the limit parameter to the maximum number of items that you want. For example, suppose that you query a table with a limit value of 4, and without a filter expression, the query result contains the first 4 items from the table that match the key condition expression from the request. Now suppose that you add a filter expression to the query. In this case, DynamoDB applies the filter expression to the 4 items that were returned, discarding those that do not match. The final query result contains 4 items or fewer, depending on the number of items that were filtered. Counting the items in the results. The query response contains the following elements: scan count and count. Scan count is the number of matching items to the key condition expression before the filter expression, if present, was applied. Count is the number of items in the response result. If you used a filter in the request, then count is the number of items returned after the filter was applied. If the size of the query result set is larger than 1 megabyte, scan count and count represent only a partial count of the total items. You need to perform multiple query operations to retrieve all the results. Capacity units consumed by query. If you query a table, DynamoDB consumes read capacity units from the table's provisioned read capacity. If you query a global secondary index GSI, DynamoDB consumes read capacity units from the index's provisioned read capacity. In the case of a local secondary index LSI, DynamoDB consumes read capacity units from the base table's provisioned read capacity. DynamoDB calculates the number of read capacity units consumed based on item size, not on the amount of data that is returned to an application. Read consistency for query. A query operation performs eventually consistent reads by default. This means that the query results might not reflect latest changes due to recently completed put item or update item operations. If you require strongly consistent reads, set the consistent read parameter to true in the query request. Paginating query results. With pagination, the query results are divided into pages of data that are 1 megabyte in size or less. An application can process the first page of results, then the second page, and so on. To determine whether there are more results, you need to query with the debug mode in order to examine the low-level query result and check if the result contains a last evaluated key element. In this example, the query also limits the number of items per page using the page size parameter. The query result contains information in the last evaluated key. This indicates that there are more results data available for the operation. To retrieve the next page of information, you will need to set the exclusive start key value to the last evaluated key value, and query again, until the absence of the last evaluated key in the query result. When there is no last evaluated key, you have retrieved the final page of results.